Okay, PLP geometry. This is our, we're still in Unit 7. This is our video number 2B, right? So let me head this up. This is number 2B. And again, we are still doing volume of prisms and cylinders. Prisms and cylinders. So again, I just have 3 more examples to go over. And again, just trying to give you all the different kinds of problems you're going to see so that you can problem solve. And again, this is all about problem solving, right? That's what we're doing. Okay, so let me change colors. Let's do an orange example. So this example, this would be example 3. Okay, so it says we have a cast iron pipe. So we have a pipe. Okay, the outer diameter is equal to 14 inches. The thickness of the pipe material is 0.6 inches, and we want to find the volume, to the nearest hundredth. Okay. So here is the picture they're going to give you, right? So you're going to see a cylinder, and it's going to be on its side, not up and down. So here's the one circle. I'm going to do dotted for the back one. Let's connect it. So then okay, so there is the pipe. However, right, this pipe is hollow. So I'm going to put the word hollow nice and big. Right, it's not a I don't want to say concrete, but it's not like the whole thing's not made of pipe, because then nothing could flow through it, right? So it's hollow. So there's another cylinder inside of it cut out. And again, I'm not going to continue that, but hopefully you understand the picture that this pipe is hollowed out. So we need to find just the volume of the material that helps make the pipe. So what this is going to be, right, is this is a volume equals, and we're going to take the volume of the outer cylinder and subtract the volume of the inner cylinder. So it's just 2 volume of cylinder problems. Now let's just remind ourselves over here that again, it's pi r squared h. Because it's a cylinder, this pi r squared h is the area of the base, right? Okay. So now over here, it says the outer diameter is 14 inches. That means that this is 14 inches. Now the one thing it did not give us up here, but it's going to put on the picture, is the length of the pipe. So this pipe is 20 inches long. Okay, so that's for later. So I did not put that up here. Okay. But now they give us this thickness. So this thickness is 0.6 inches. What this means is that this space, I'll change colors in here, this space here in green, right there, that's 0.6 inches. And so is this space over here, 0.6 inches. What this is going to help us do is get the inner diameter. To get the diameter of the inside, we need to take the diameter of the outside and subtract this thickness twice, 2 0.6s, because it's on both sides. When you do this, you're going to get 12.8. That is this diameter right there, 12.8 inches. Okay. So now notice over here, it says R. Well, for our 2 diameters, we have a 14 and a 12.8. We need to take half of those. So for the radius of the outer, we must take 14 and divide by 2. That's 7. And for the radius of the inside, we have to take 12.8 and divide by 2, which is 6.4. And now we have it. We have our 2 formulas. Okay. So we're going to do volume of the outside equals pi times, I'll just use a parentheses, 7 squared times 20. And again, if we multiply that out, and I don't want you to round too soon, right? If you multiply that out, you get 3078.7608 ... And then the volume of the inner is going to be pi times 6.4 squared times 20. And if you multiply that out, you get 2573.5927 dot dot dot. Again, try not to round. And now just in Desmos, you're going to take those, you're going to copy and paste those two numbers and subtract them. So to find the volume we want, we're going to take the 3078.7608 dot dot dot, and we're going to subtract the 2573.5927 dot dot dot. And when you subtract those, you get a volume of 505.168. And I stop there because it says nearest hundredth. The 6 is in the hundredths. The 8 is going to round the 6 up to a 7. So that is 505.17, and this is volume. So that would be inches cubed. And that is the amount of pipe you need to make this hollowed out, or the amount of whatever material you need to make this hollowed out pipe. It's a really good problem. I like this. And again, this is real world stuff, right? Okay. All right, perfect. All right, next example. Okay, so this is going to be example 4. So this is our 4th example. Okay, so we have cylinder A has a diameter equal to 12 feet, a height equal to 14 feet. Okay. All right. So there we go. Then we have cylinder B, which has a diameter of 16 feet and a height of 12 feet. Okay. And it says, right, A is full of water. A is pumped into B. That word is pumped. Let me rewrite that word. It's kind of hard to see. Is pumped into B. So that means all the water from A is poured into B. The question is, what percent of B is empty? To the nearest tenth. Okay, so this is an intense problem. It takes a couple steps, right? But again, it's very similar to the last problem where you have 2 cylinders you have to find the area, the volume for, right? Just this little percent stuff at the end is a little bit different. Okay, so let's take cylinder A. Okay, so cylinder A, so the volume of A. Again, it's a cylinder, pi r squared h. Again, that area of the base is pi r squared. So this is going to be pi. Now it gives me the diameter is 12. So to find the radius, we take half of 12, which is 6. So it has a radius of 6. So 6 squared, and then the height is 14. I'm going to change a little bit lighter, sorry. Okay, when you type that into the calculator, I did not multiply out the pi this time. Remember last problem, I did multiply out the pi. So this time I'm showing you that if you don't multiply out the pi, you don't have to write as many decimals. So this is 504. So when you just type in that, 6 squared times 14, you get 504, and then just attach the pi onto it. Okay, so that is the volume of A. So now let's find the volume of B, and I'll change the yellow. Pi, r squared h, pi. Again, the diameter is 16, so to find the radius, take half of that, which is 8. So pi times 8 squared, and again, its height is 12. And again, if you just multiply out the numbers, you get 768 pi. So notice that the volume of B is bigger than the volume of A. That's why when you pour all of A into B, there's some empty space. We need to find how much empty space. To find the volume, I'll change color again. I like to change color. To find the volume of the empty space, we're going to subtract the volume of B, 768 pi, minus the volume of A, 504 pi. When you do this, you don't need to put the pi's. Think of the pi's as x. You're just going to subtract the 768 and the 504. You get 264 and just put the pi with it. Okay? And now, that is the volume of the empty. To find this percentage, you always take the volume of what you have or what you want and divide it by the total. So to find the percent empty, you're going to take the volume that you are empty and you're going to divide the volume of container B, the total volume. And then once you do that, you're going to multiply by 100 to get the percentage, right? And they want the percentage rounded to the nearest tenth. So this problem would be 264 pi divided by 768 pi. Now, because we never multiplied out the pi's, when you divide these two, you can feel free to cancel out the pi's and not even worry about them. You can type them in Desmos if you want to, but you don't have to. So you're just going to do 264 divided by 768, and you're going to multiply that by 100. And the number I get is 34.37. I'm going to round to the nearest tenth. That 7 rounds a 3 up to a 4. So this is 34.4, and that's percent. And that's how empty, that's how much empty, percent empty, container B will be once all of A's water is poured into it. On Delta Math, there's a cool graphic that they show you. So you can take a look there when you do those problems. But this is, again, just boils down to 2 cylinders. Okay, and then last but not least, we're going to do a density problem here. So this is your last example. This is example 5. Okay, so it says a water sample shows 0.017 grams of trace element. And again, I'm a little confused what trace element means. Maybe just like some element in the water, right? Trace just means a small amount, I think. For every cubic inch, centimeter. Okay. So we have a container is a cylinder. Okay. The radius equals 5.7 centimeters. The height equals 13.6 centimeters. And the question is, how much trace element is in the sample? Okay. It really should say, what weight, right? But it says how much. How much trace element is in the sample? Question mark. And you might be saying to yourself, Mr. Java, why is this density? What are you talking about here? I see some centimeters, whatever. It's this idea right here. Grams for every cubic centimeter. This 0.07 is the density. The density is 0.017 grams per centimeter cubed, mass per volume. Okay. Now, what they do is they give us the dimensions of the cylindrical container. We're going to be able to find the volume of that cylinder. Okay. So remember, density is mass over volume. When we have the density, we're going to find the volume. That means we can then solve for the mass. So let's find the volume. It is a cylinder, pi r squared h. Again, the area of the base is pi r squared. The radius is 5.7. The height is 13.6. It's just a simple plug and chug. So we have pi times 5.7 squared times 13.6. When I plugged that in, I got And again, I'm not going to round, 1388.156696. And again, leave that alone. So now I'm going to take this formula right here. I'll do it in yellow. I'm going to bring it right there. My density is 0.017 equals the mass we're trying to find, but my volume is 1388.156696. And what we're going to do is we're going to multiply both sides by this 1388.156696, both sides, times 138.156696. We're multiplying. And when we multiply, we're going to get an answer, and that answer is 23.59 equals our mass. It said to the nearest tenth. It didn't say anything, but we're going to do the nearest tenth. 5. The 9 rounds the 5 up to a 6, so we're going to say it's 23.6, and that would be our mass, which is in grams. And that's how much trace element is in this water sample. All right, so again, take some problem solving, right? So again, not simple, but I think you can do it. So do your best, ask questions when you have them. We'll see you in class.